All right, well, it's 12:03. Looks like we're pretty close to quorum. So again, thank you all so much for being here. And why don't we get started? So my name is Madeline Rose. I'm the Climate Campaign Director for Pacific Environment. I'm really thrilled to co-host today's webinar with Lacey, the LA Clean Tech Incubator. So again, you are here at California Let's Electrify Boats, introducing the technology for zero-emission harbor vessels. We're so excited for this to really, in this moment in time, to help build awareness, momentum, and excitement, quite frankly, for the zero-emission maritime transition here in California and around the world. Just to sort of global set us in this moment before we get started, mitigating global climate crisis requires unprecedented pace of industrial transformation this decade. Just last week, the UN Environment Programme's annual production gap report found that world governments are on path to produce 110% more fossil fuels this decade than a 1.5 degrees Celsius carbon budget allows. In other words, we are still not on path on a decarbonization trajectory that is sufficient with a healthy, livable, stable climate. This requires massive innovation at a scale, quite frankly, that is new. And that includes in the maritime sector. So globally, the maritime sector is working on transformation across the board. At the United Nations, countries right now are working to negotiate a more ambitious target for global shipping decarbonization, looking at 100% zero greenhouse gas emissions by no later than 2050. On the container cargo side, just last week, a coalition of major cargo owners, including Amazon, Unilever, IKEA, and Patagonia, just committed to moving all of their cargo off of fossil fueled ships by 2040. And on the land side, port side transition, we're seeing a lot of innovation in battery infrastructure, storage infrastructure, and the fuel side transition that we're going to need in order to service these new zero emission ships. But ultimately, a lot of where this, where this innovation is coming down to and starting is with the vessels we're talking about here today. So ferry operators, tugboat operators, all of the harbor vessels, that's a lot of where we're testing and learning what technologies work. So we're so excited to bring some of the leaders of this movement here together today to tell you about, what is the technology looking like? What are we learning? How do we take it to scale? So with that kind of global context, I'm going to pass it over to Michelle Kinman of the LA Clean Tech Incubator for some framing on how this impacts California specifically. So Michelle, over to you.
Great, thanks, Madeline. My name is Michelle Kinman. I'm the Senior Director of Transportation at the Los Angeles Clean Tech Incubator, or LACI, which is a little easier. And we at LACI could not be more delighted to join together with Pacific Environment to co-host this webinar on zero-emission solutions for marine applications. I will note that my colleague Jack Symington is also on the line here, who manages much of our goods movement work. And we're just thrilled to be here with you all and to learn more about the state of zero-emission marine solutions. Just as quick background for those of you who may not yet be familiar with LACI, we're a nonprofit organization based appropriately in Los Angeles that has a mission to create an inclusive green economy. And we are tackling that with three key strategies. The first, as you can see here, is unlocking innovation, working with promising clean tech startups to accelerate the commercialization of clean technologies. We are also working to transform markets through partnerships with public and private entities in transportation, clean energy, and sustainable cities. And then last but not least, we're working to enhance communities through workforce development, pilots, and other programs. Next slide. And those of you who know LACI well will know that we focused a lot of our efforts over the past few years on zero emissions transportation solutions. Most notably, we've convened the Transportation Electrification Partnership, which is a public-private collaboration with more than 30 members, some of whom I see are on the webinar today, that is really focused on accelerating deep reductions in climate and air pollution in the greater Los Angeles region by 2028. And that's the year when LA will be hosting and welcoming the world to the Olympic and Paralympic Games. And through this partnership, we have really focused our efforts to date on transitioning on-road transportation to battery electric solutions. But even so, we recognized very early on that as a region, we really need to begin investments in marine applications in order to make sure that we're making those deep reductions in both air pollution and climate emissions. This is an important issue for today, as Madeline stated, given that Harborcraft currently contribute a substantial amount to the emissions inventory of both the ports of LA and Long Beach. So we're seeing this right here home in our region. In 2019, which is the most recent year with a completed inventory, Harborcraft accounted for 24% of all diesel particulate matter. That's, as context, more than twice as much as on-road trucks and terminal cargo handling equipment combined. So that's pretty significant. And then in addition, Harborcraft were responsible for 11% of all NOx emissions and 6% of all carbon dioxide emissions. And that's about the same contribution as rail in both categories. So that's all to say that Harborcraft are a significant contributor to the port air quality that burdens communities surrounding the ports, and really provides a strong impetus for the sector to begin to address how to reduce emissions and to achieve our regional and state climate goals. Fortunately, there is strong precedent in California for leading the way on the regulation of and investment into technologies that are truly essential in creating a zero emissions transportation future. As many of you who are based in California well know, CARB, the California Resources Board, has or will soon implement zero emissions regulations for transit buses, airport shuttles, trucks, cargo handling equipment, and transportation refrigeration units. And then on top of that, CARB, the California Energy Commission, and the San Pedro Bay ports and others have really worked long and hard to ensure that the industry is able to reach these equipment standards with significant investments in both demonstrating and piloting innovative technology. And so I think the opportunity is really right now to build on these successes. We have this great opportunity in California to craft a regulation to aggressively transition marine applications feasible today to zero emission technologies. And so this is, important on a number of fronts. It's important not just for protecting our communities surrounding the ports. It's also important for preserving our coastline and frankly, for setting an example for the entire country as we move forward to create a zero emissions economy. And so with that in mind, I'm just really excited to learn from the real world experiences of our expert panelists today, and then to think together about the policies and the funding structures that are going to be necessary to accelerate the deployment of zero emission marine technology. So with that, I'll pass it back to you, Madeline.
Thanks, Michelle. We're so thrilled for you to be here and learn from you as well. And so with that, we're excited to kick off the really exciting panel. So our first, and again, we have some of this, the frontline leaders and researchers in this sector with us today. So thank you all. Thank you all of you for being here with us. Elias Van Sickle is going to be our first speaker. He's the Director of Operations and Commercial Development for Switch Maritime, which is working to build the first fleet of zero emission vessels in North America to catalyze the decarbonization of maritime shipping. Switch's flagship ferry project is a long-awaited hydrogen fuel cell passenger ferry that will be in operation soon here in the Bay Area. And I know I speak for everyone on this panel that we all can't wait to be on it, Elias. So tell us about it, and over to you.
That as I said, I'm Sickle, Director of Operations and Commercial Development Maritime. I'd like to start by just environment and Lacey for having us and for organizing. And with that all, let's jump into the next slide, please. So just to start by zooming out a big picture, I'll go through this pretty quickly because I think you're probably familiar and some of these kind of, but the mission that our work is one that we see as a very large, and that's the CO2 emissions and particulate matter emissions of the shipping industry. So shipping is around 1 billion tons of CO2 a year, and that's expected to go up. We don't do anything. Let's see if I can turn the video to improve the audio quality. Can you all hear me?
Elias, you're a little choppy. So everyone, Elias is joining us from Germany today. You're a little choppy, but why don't the speakers, if we can go off video, let's see if that gets a bit better.
All right, so sorry about that. Here, I'll try to improve my Wi-Fi.
There you go, you sound better.
Okay, great. And so moving on to the reason that the shipping industry has been tough to decarbonize is a number of primary reasons. One is the enormous energy requirements, the high capital costs for these large, long-lived assets, and then the large infrastructure that's required to support fueling. And so with that, we'll go to the next. So this is just a high-level overview of the path to zero carbon that we see the ship taking. Switch is motivated and working on that last box down at the very bottom, which is the full zero carbon options. This path to zero emissions is one that will take time, but we really see the work of Switch as catalyzing that shift towards zero. So we'll go next slide with that. So one of the big points that I want to drive home today is that zero emissions vessels are possible now. The technology does exist. What we're doing is integrating these available and widely distributed zero carbon technologies into maritime applications. So the Change, which is the ferry that I'll introduce in a second, is just a first-kind application of this zero carbon technology. And so while the technology does exist, the challenge that we face is that there is a fair amount of complexity and risk associated right now with making that transition. And Switch's objective is to help the industry by making that transition easier and shouldering some of that complexity. Next slide, please. So what we believe electrification using both battery as well as fuel cell has potential to address the hard to decarbonize high horsepower sectors such as maritime shipping. And really what Switch is looking to do is both create the zero emissions vessels and then also support those with the clean supply infrastructure and then make those assets, the zero carbon vessels, available to existing operators and municipalities in an efficient way. So that's through simple lease structures like a bareboat charter. Yeah, and with that, I'll go to the next slide. Next slide. More slide. Great. As Madeline mentioned, the first that we are working on is the Sea Change, is our vessel. It's a 75 70-foot passenger ferry powered by hydrogen fuel cell and battery. Change has 264 kilograms of hydrogen storage on board, 360 fuel cells, 100 kilowatt hour lithium ion battery, and those electrons are sent to 300 kilowatt electric motors. And so again, the architecture of the propulsion system in the Sea Change really isn't all that similar from some of the predecessors that were hybrids, such as hydrogen on the West Coast and then smaller vessels East Coast. What we're doing is taking out the diesel generators, replacing those with fuel cells. We have our zero carbon architecture. Next slide, please. Great. So also, these are some pictures. Launched the Sea Change on August 12th, which was a very exciting milestone for us. It's underway for now, and we're getting to the final stages and are at the finish line and to be up in San Francisco. This is just a picture of the vessel on the water side. Next, please. Great. The bit of construction timeline here of the Sea Change. Go to the next slide. Super. All right. So this a bit of look at each of the technologies that are primary zero carbon technologies integrated in the Sea Change. On the top deck, we have the hydrogen storage system. Those are the compressed gas hydrogen storing at 250 bar. The picture is the fuel cells. As I said, we have 306 kilowatts, come in 3 kilowatt modules. And the point to me here is this technology is incorporated in a ferry, and the ferry is really the smallest version of what we hope to get to, which is really scaling this technology to much larger vessels, and the battery modular and scalable. So the hydrogen flows into the tanks, the fuel cells, creates electricity. That electricity gets directed to and or system, depending on what the vessel's power needs are, and the electric propulsion system spellers that move the boat. Next slide. Next. Great. You can skip through the next couple slides. These are just some pictures of the vessel launch to give a sense of where we're at. Sorry, I just want to pause one real quick. I'll just speak to the project partners. The project partners wouldn't have been able to get this done, all the support that we have from many project partners, including a ton of support from the state of California in a bunch of different respects. And we'll talk to that a little bit later, probably in the Q&A, but we've had a grant from the state of California, the CARB, California Resources Board, a loan guarantee that was the first award under the Climate Tech Finance Program, which was a Bay Area Air Quality Management District program. And then that loan guarantee was administered by Cal SC and California iBank. Next slide, please. This just real briefly shows kind of Switch's position is that zero carbon is not just a mental decision, but it's also an economic one. And as you heard in the beginning, there are regulations coming along the road soon that make these future-proof solutions something that is, first of all, required and minimizes or completely eliminates exposure compliance risk. So we see that as one of the big drivers from a pure technology standpoint. These technologies are in many ways more attractive than your conventional internal combustion engines. Next slide, please. So this speaks to a bit of the overall costs that going presently and then going as well. Right now, we do see a bit of a premium both on the CapEx side as well as the OpEx side for fuel. In a total cost of ownership framework, though, over time we see reaching parity in about 5 to 7 years, and then in the long term that going to a discount on a total cost of ownership basis. Next slide, please. Great, and then I'll just run real quick through the hydrogen fuel supply chain. You can't have an electric car without an electric charging station, and nor can you have a clean fueled vessel without the supporting infrastructure to fuel that vessel. And so Switch is working with a partner company of ours, West Coast Clean Fuels, that will manage the fuel delivery for sea trials up in Bellingham and then also down in the San Francisco Bay Area. And West Coast Clean Fuels will manage the permitting with the US Coast Guard, the fire department, the city, and all local municipal entities that are required in that permitting to develop the fuel supply chain. And so this is leveraging experience that West Coast Clean Fuels has in the LNG space. Currently, West Coast Clean Fuels is also managing the US Coast Guard process and developing the fuel supply chain for Pasha Hawaii's container ships that are going to be fueling out of the port of LA Long Beach, and they will be the first LNG fueled container ships on the West Coast. Next slide. Great, and then this just shows a bit of the detail on how the sea change will be fueled. It's going to be a cascade fill going from compressed hydrogen in the trucks over to the compressed hydrogen tanks on our ferry. And with that, I will conclude and pause for the rest of the presentations, and happy to get into more detail in the Q&A. Thanks so much.
Thank you so much, Elias. And thanks everyone for bearing with us on some transoceanic audio here. But Elias, you came through the last few minutes really strongly. So keeping us on the theme of ferries, our next speaker is going to be Graham Balk, the managing broker from Green Yacht. So Graham has been working at the intersection of business, boating, and environment throughout his entire career. And that's part of the reason why he helped start Green Yachts. As the managing broker at Green Yachts, he oversees recreational and commercial sales, business operations, strategic partnerships, and boat builder relationships. And Green Yacht has signed agreements with over a quarter of the short-run California passenger ferries that are going to be required to go electric this decade. So it's certainly right on the front line of figuring out this propulsion system for many additional passenger ferries in California. So Graham, thank you for being here, and over to you.
Hello, everyone, and thank you for being on this webinar. I would love to chat about some of our technology and what makes it safe and efficient, but I think there's a more important perspective that I think would be helpful for all of the policymakers that are on this call. So if I could ask everyone, just take a second and close your eyes. I'd like to take you out of your policy position. And for just a minute, I'd like you to step into the shoes of Maggie, who owns and operates the Angel Island Ferry. She's the first of the 15 or 16 passenger ferry vessels that are going to be going zero emission in California. And I think it's important as policymakers to understand what it's like to be in her shoes. So you're a fifth generation woman-owned small business with about $1 million in revenues, less than 100K in net income. And you've got a 15 to 20 minute turnaround time between ferry runs. And you've got to get a massive high-speed charger onto your deck, 660 kilowatt hours of battery banks into your boat. And it's going to be a $2.7 million project that you have to finance all up front. And $600,000 of that comes out of your pocket. Remember, your net income is less than $100,000 a year. And you're taking on a $2.7 million project that you have to fund all up front, 600,000 of which comes out of your pocket. And that's after lawyer funding. So just think about what it's like to be Maggie staring this down. She is absolutely on board. She's gung-ho about going electric. And I think that's what all of the policymakers and advocates on this call want. A marine operator who's willing to go first, who's willing to go electric, who's excited about going electric. That's Maggie. But she's also scared because she's staring down this project and she doesn't know how she's going to do it. And she's not the only one. This is the situation that a lot of small businesses that are being asked to implement these policies are feeling. They're on board, but they're not sure how they're going to do it. And part of the problems, and you can go to the next slide if you like, part of the problems is that the on-land portion of the project is very expensive. Getting a high-speed charger out to the end of a dock in a marine environment and charging up 2 or 3 Teslas worth of energy in 15 minutes is a really hard task logistically, let alone for a small business. Maggie's reached out and tried to find project financing, but there's no product that makes this possible, and she can't get emails or calls returned from GoBiz, the governor's small business finance center. So she and she's also wondering, why is it that these short-run ferries, a lot of which are owned by small businesses, are the ones that have to go all electric, all zero emission, and nobody else has to do this on their existing boats? Why is this falling upon the smallest operators in California? She's wondering how that's fair. Again, she's willing to do this. She just wants it to be possible. And then she's asking questions like, well, what about my backup boat? Because your main boat is always out of service at some point during the year. Am I allowed to operate my backup boat? Or do I have to spend millions of dollars converting that to electric, even though I use it for a couple hundred hours a year? How is the cost of the electricity going to cost compared to the diesel? So I think it's really important for all of you policymakers who are doing great things to advance this electric revolution, this zero emission revolution on the water. I think there are many folks who are excited about implementing the policies and goals that so many of us have. And Maggie is in the position of asking how she's going to do it. We have a few ideas. Next slide, please. So if California is asking these small businesses to do these big projects, somehow we've got to find a way for a 0% loan or low interest loan to be automatically granted alongside a Moyer grant, so that a small business doesn't have to finance the project all up front. These big projects, way bigger than their revenues and their net income, provide an automatic financing option for them to be able to fund these projects from the get-go and not get funded afterwards. Number two, the on-land portion of these projects, these electrification projects, are quite expensive. And the on-land portion for Maggie is going to be half of her out-of-pocket costs because the reimbursement rate from Moyer funding is lower. How can we make sure that the whole project is funded? Because this is a whole project for Maggie. It doesn't matter to Maggie, the percentage reimbursement here, the percentage reimbursement there. What matters to a small business is what do they have to pay out of pocket? And if the reimbursement rate for onshore charging is so much lower than the on-vessel portion, then that becomes her biggest headache and an issue that as policymakers and advocates for this, that we need to help solve alongside Maggie. Three, the proposed commercial hovercraft regulations don't have any guidance about what happens relative to a backup vessel. What happens if Maggie's vessel is out of service because she needs the bottom painted, or anything not related to the electric propulsion, which happens fairly often, as any marine operator can tell you. What happens then? I think that question needs to be defined. And then fourth, Maggie, understandably, feels that CARB should be requiring short-run ferries to go electric with no electric requirements for other vessels. Make it a sliding scale based on the percent of hours zero emission, similar to the low use exemption sliding scale that CARB has on engine tiers. In other words, Maggie's asking, why is it that the smallest operators are bearing all the burden and not having some graduated requirement for everybody based on the distance they travel per day, et cetera. So thank you for everybody on the call stepping out of your own shoes, your own perspective for just a second, and thinking about what it's like to be the first of the short-run ferries to go electric in California. And the reason why stepping out of your shoes and seeing Maggie's perspective is important is because our policies are all designed to achieve this electric zero-emission revolution on the water. And we all need to be thinking about how do we help Maggie do this. And if anybody wants to talk with me or Maggie, ask questions, offer help, we'd be happy to talk with any of you about any way that we can make this possible for Maggie to be the first in California of the short-run ferries and set an example to everybody else. I know of at least one other person on this call who would be more likely to go zero emission if they could step on Maggie's boat and feel it and see it operated and ask Maggie what it's like. Help Maggie be the first in California. Get in touch with us because we want this to succeed. Thanks.
Thank you, Graham. I feel like Captain Maggie Go ZE could be a bumper sticker or something in the Bay Area and a tagline. But yeah, thank you so much for breaking down, the very real process here. I think that's a great segue into our Q&A. I know there's a lot of questions about financing and scale. So appreciate you kind of teeing those up for us. Our next speaker is going to be Xiaoli Mao, who is one of my favorite people in the Clean Maritime movement. We're so lucky to have her here with us today. Xiaoli is a senior researcher for the International Council on Clean Transportation and has done a lot of work both on the landside green hydrogen infrastructure transition that we need along the Pacific Rim and in California. But in particular, why we invited her today, she's also done some of the leading research on the zero emission transition for commercial fishing vessels, which is another tough segment to focus on. So Xiaoli, thank you for being here, and over to you.
Thank you, Madeline. I'm honored to be here today. If I can, so thanks. So my topic today is about repowering the fishing fleet with batteries. Next one, please. But before that, I will introduce a full spectrum of the zero emission vessel technology analysis that we do here at the ICCT. We believe that it's not going to be a one-size-fits-all type of solution for decarbonizing the shipping industry, but rather it would be a combination of different technologies and fuel options for different segments, implementing in different timeframes. And here at the bottom, we believe that the full battery electric or so we all know that the battery, compared with the fossil-based fuels, has very, very low energy density. So that makes the reduced range of using batteries a huge challenge for longer range applications. But how limited? We actually we use the real world ship operations data in 2019 to model a set of theoretical ranges for different ship types using the battery electric technology. And here I just listed some of the harbor craft categories, and we can see here for fishing vessel, which is to the very right, it has shown very limited range, somewhere around 600 or 700 kilometers. But I should mention that we assume a relatively conservative assumptions on battery technology, which is about 200 kilowatt hours per ton. That is 1/50 that of the distillate fuel. Next slide, please. So recently we have been doing some studies focusing primarily on the larger fishing fleet that are active on the Dutch harbor region, because we know it's a very active fishing port. We analyzed the feasibility of using battery electric technologies to repower these ships. And we found that the attainment rate, which is defined as the share of voyages that these ships can make using battery electric technologies, compared with the total number of voyages that they're supposed to make, the overall attainment rate is actually promising from our point of view. These vessels are relatively large. They engage in relatively longer average, trips, length trips. And although the trawler subsegment among these vessels show relatively lower attainment rate, which is due to huge energy consumption during their active fishing activities, the overall attainment rate is actually not too bad. I should mention that these are also using the relatively conservative battery technology assumptions. And we also actually modeled the feasibility of using hydrogen fuel cells on these very same ships, and it's showing across the board very high attainment rate, which is, I believe, over 95%. Next slide, please. we found that the trip length, which is how long that the ship has to go out on a single trip between the refueling between the berths at the port, is the determinant factor for attainability. So a shorter trip lengths for relatively larger vessels are more able to attain using this technology than the others. Next slide, please. We also identified some ways to improve the attainment rate. In the short term, you can definitely implement some energy saving practices, including speed reduction. And there are growing interest in utilizing the diesel battery hybrid solutions, which are showing to be fuel saving, if not consider other benefits. In the longer term, though, we can rely on battery technology improvement for sure. And the other hybrid option, battery hydrogen, is actually looking more promising. Next slide, please. I'd like to point you to some other research that are on this same topic and are arriving at similar conclusions as ours. But I'd like to point you specifically to a Maine state lobster fleet decarbonization study, which looks exactly at the feasibility of hydrogen fuel cells and battery technologies in particular. And this study is going to be out very soon. So I would encourage all of you to follow that. Next slide, please. Here are some real world cases of fishing vessels using battery electric technologies. Unfortunately, the ones, I guess there are likely more of these cases, but these are the ones that I found so far. They're all using Corvus energy storage systems. They're all, I believe, Norwegian vessels. But as you can see, there are both hybrid and full electric ships, fishing vessels that are on the water today, but they're relatively small in scale. Next slide, please. There are some issues to consider, though, beyond the technical feasibility or the benefit of saving the environment. So there are the benefits of using battery electric technology include no charging time constraints for as compared with the ferry segment, which is mentioned previously. And there's this added benefit of reduced noise and vibration while you're actively fishing. So that's a huge benefit. There are also many other issues to consider that are concerning for the battery applications, including one of the issues that I found is that a comprehensive energy audit for the fishing vessels is very lacking. When we talk to fishermen, they're all one of the common comment is that different vessels, even individually different vessels, their energy consumption profiles are vastly different. So without a comprehensive energy audit on all those vessels, it's very difficult for policymakers to get a full picture of how the industry is doing and how to implement different strategies to make it better. I won't go through all the list, though. Next slide, please. I would like to end with some key takeaways. So I think that the current battery technology can be used in current fishing fleet to not only save fuel cost, but reducing emissions at the same time. The battery technology will continue to advance and the cost will almost definitely continue to drop. And the electricity that these batteries use will get cleaner over time, so delivering more climate benefits over time. The batteries play different roles in different fishing subsegments, so I'm not claiming that it's the right solution for everybody, but I think a full electric and a hybrid solution could be considered for your own applicational scenarios. And finally, the energy audits, comprehensive energy audits are very needed, not only to help the policymakers, but to help the fishermen themselves understand how they are currently doing and how they can implement different ways to save fuel cost while being responsible to their local environment. I'll skip this part because I know my time is limited, but I'm happy to answer any questions in the Q&A. And thanks.
Wonderful. Thank you, Xiaoli. I imagine there's going to be some follow-up questions on this segment, certainly in the Q&A, I hope, which might I remind folks then in the attendees, please do remember that you're welcome to drop questions either to me directly or in the chat. But continuing on the theme of batteries, we are very excited to now pass it over to Brent Perry, the CEO of Shift Clean Energy. Brent has spent 30 years working in the maritime industry as a boat builder and was drawn to create the first lithium energy storage applications about 15 years ago. So they have been working on electric and hybrid installations since sort of on the technology side for about 15 years, and their first installations in 2011. So Brent, thank you so much for being here. Brent is also joining us from overseas in London today. Over to you, Brent.
Hi, everybody. Next slide there, please. Again, my name is Brent Perry. I think I can comfortably say I have a long history of road rash and scars in this space, and have experienced or been a participant in many of the firsts of the industry, as well as many of the learning curve elements of the industry. Can you go to the next slide, please? So we started into this space learning how to actually apply the technology of lithium into energy storage and really into marine. And that was initially the fundamental thing. Can you guys go to the next slide, please? That was really the fundamental question of how do you address the needs of the maritime industry? And the needs of the maritime industry are fundamentally different than almost any other industry that uses energy storage. The marine applications need to have the 24/7, 365 reliability that is a part of our ability to turn propellers and make money. The second element they have is risk management. There really is no room for failure when you're talking about propulsion power. And then the third simply is you have to be able to deliver, commercially speaking. If we don't make money, then we don't really engage in any technology. So with all those challenges in mind, we spent quite a few years really looking at the cell industry and trying to decide whose lithium cells would deliver those kind of value propositions and share those kind of purpose goals with us. Then we looked at the issue and what you see on the screen here. This is simply the reality of the day. The marine industry has always been focused on delivering cost to its shareholders, quite often at the expense of the environment and the societies that they work within. One of the reasons why ports are seen as some of the largest polluters in almost every community that they're involved with. So when I started doing fixed battery installations back in 2011, the question was what markets, what verticals do those make sense in? And the initial markets were tugboats and ferries, and really ferries took ownership of that space. And even though we've installed everything from oil and gas platforms to different types of surface and subsea vessels, to ferries, to even now we're doing short sea and long sea vessels, the reality was the fixed installations, if you can go to the next slide, please. The fixed installations faced a lot of challenges and still do. You're dealing with a very large battery when you're trying to build a system that's going to last 10 years, because effectively you had somewhere between 30 and 40% of the capacity you need at the end of 10 years in order to have enough battery at the beginning to survive for 10 years. So that meant that you have bigger, heavier, more volume that you're dealing with and managing. And that also meant that you had higher capital costs initially than perhaps makes a lot of sense. And then there was always issue of range and performance, and a battery system The heavier it gets, the more detrimental the performance can be. And so initially we looked at very large vessels that could support that kind of capital structure. But of course, as we started to develop successfully and we were delivering good payback on these systems, the market has gone down to the point where Maggie is now our client. She is the kind of person who is looking for zero emission solutions on very small vessels, even down to 25, 30-foot ships in ports, in ferry operations, many different applications. And for them, size and weight and range and capital requirements are even bigger issues. So we took a really good look at this again. Next slide, please. And asked ourselves, how can we turn the dial 1 degree to enable energy storage to bridge a lot of these gaps and bring a solution to markets that currently there is no very good practical solution for. And part of that's for both a good system, and part of that's also to extend the range of time on other technologies that are going to be improved to become viable commercial solutions as well. So what we've come up with, and I think Shift is the first company in the world to introduce this concept, is effectively a subscription-based service where instead of buying a 10-year battery life, you're literally entering into a per trip battery life. So what we're doing is taking the capital risk away from the operators and putting them in a position where they're paying for this like a software subscription, like any kind of a service subscription. And we're taking responsibility for the supply of not only the energy storage, but all of the power electronics that's associated with it, everything including the charging system. As Graham very accurately pointed out, the batteries have lost cost over the last decade pretty significantly, while the charging systems, if anything, have become more expensive. And the need for fast charging, which is a very detrimental element, but incredibly important to not change the parameters of operation of the systems managers, is putting a lot of stress on the aging of the batteries, and it's also putting an incredible stress on the cost. You need much bigger charging infrastructure to deliver 10 megawatts in 6 minutes, and as we do in some applications. Next slide, please. And we're doing that by creating an energy storage system that can literally be loaded and unloaded on the ship at the convenience of the operator, with enough capacity to make a return trip or 2 return trips, or whatever the binary needs to be. And we've now addressed that in terms of creating energy storage into an IP67 container. This is our 70 kilowatt hour module, if you want, that is an A60 machinery space according to all the type approval requirements in the world. So this takes away the cost of adding all that element to the vessel as well. And it allows the operator to now basically to and from on their trip, and when they land, take off the energy storage systems that are fully discharged and re-engage with the energy storage systems that are now fully charged. And we can do this in a fraction of the time it takes to actually charge. So one of the benefits of this is it allows us to charge the batteries at a speed that enables us to gain the optimum cycle life out of these battery systems. When you charge a battery at a 3C or something, 3 times its capacity rate, you will actually age the battery by about 50 to 60%, depending upon the technology, which significantly shortens its life, which means that the cost of energy it produces is more expensive. By enabling the operator to take full advantage of the complete cycle life of the battery, we literally are cutting the cost of the energy produced almost in half, which makes it a better effective. Next slide, please. So by being able to do this, we take charging time away as a barrier for operations. We do have to have the infrastructure to engage the batteries onto the ships, which is going to involve a crane structure of some sort. But that's part of our issue in terms of providing this as a service. We don't just provide the charging infrastructure and the battery system. We also, in most cases, would end up operating that so that there's no risk to the operators of actually managing systems that can weigh several tons, up to about 30 tons, as we engage and disengage them with the ships. This is it's a dangerous space. It needs people who are highly trained. It needs people who are insurable. and it needs people who understand the risks that they're managing all day long, so that it's dedicated for the purpose of support of this space. Next slide, please. I'm trying to get through this fairly quickly for everyone's sake. And this is just a simple example. It literally can, and we're building one vessel right now in Singapore that we can do the full pod exchange on board the ship in just under 3 minutes. We're now in the midst of engineering another system here in Canada, where again, we have to be able to have the battery swapped in and out in less than 3 minutes in order for them to maintain their schedule. That's simply not possible without extraordinary costs on a fixed battery system on board a boat. On board a swapping system, it reduces the cost by anywhere from 50 to 90%, depending on the vessel that we're operating here. It's a fairly simple transaction, but it's something that does have to be managed fairly well. Next slide, please. So this is actually the boat that we are putting these on in Singapore. And this boat carries 4 70 kilowatt hour cartridges for a total usable energy of 280 kilowatt hours. And that allows this vessel to operate for about 12 hours as a crew transfer vessel in Singapore. And because the pods are A60 machinery spaces, we don't have to add a battery room to the boat, which also significantly reduces the cost. So now what you're looking at is a vessel that meets all the performance characteristics of its diesel-driven brothers. It's actually now cheaper to build because the battery no longer falls into the capital structure of the vessel, and is about 35% less expensive to operate over life for the operators than a conventional ship as well. So the benefit to these operators is that they'll be cash flow positive from day zero. They do have the opportunity now to capture, gain, and be credited for the emissions that we're no longer producing into this space. And effectively, they have a lot more latitude of operation in terms of how they actually manage this performance. So if we can just go to the next slide, please. This is the example specific to that vessel in Singapore. To do the same work that vessel needed to do on a daily basis with a fixed battery system, I would have had to install a 525 kilowatt hour battery that weighed all equipment included. And that's the safety equipment, power electronics, call it an all-in structure of about 8 tons. It would have had material costs and CapEx side of around $450,000 and been stuck with, if you want, a full charge requirement of 20 to 30 minutes. That really didn't serve their operational profile. It really didn't serve their capital profile. It made no sense whatsoever. When we engaged this vessel with the power swap system, they need 240 kilowatt hours of usable energy. They have 280 kilowatt hours of capacity. The battery weighs a fraction of that. It's about 2.5 tons. There is no capital cost down, and they do have the transition time well within the scope of what they need to do to meet their schedule obligations every single day. So it's simpler, it's easier, and it actually benefits the operators. Next slide, please. Now, in accord with this, we've developed an asset management software package that can operate on your phone or on your laptop or in your office. And the purpose of this is not only is it incorporating our very proven, if you want, battery management software that can determine the performance state of the battery and the state of health of the battery at any time, but it will actually also measure the greenhouse gas emissions that you are not producing. And you can communicate that with the IMO if that's your requirement, or any government agency directly, so they know exactly what kind of emissions you're not putting into the system. It will tell the port that you are coming in for a swap, so the cartridges that are being replaced are waiting for you when you arrive at the dock, and it'll schedule you to show you when you can come in as well. So this really is a true asset management tool that has GPS integration, has asset overview integration, has emissions management built into it, and has a very extensive systems analysis tool to look for any errors, alerts, issues that need to be managed from a service perspective. The clients we work with expect 100% uptime. That's what this is focused on delivering. Thank you very much. Next slide, please. So what the purpose of this is that this concept of swappable batteries scales from 70 kilowatt hours to about 6 megawatt hours. We get, I would call it leading industry energy density. At a 20-foot container, I can put about 2.8 megawatt hour of energy storage capacity. These can be scaled up and down to suit the requirements of everything from a very small passenger ferry vessel to even the largest blue water vessels in the world today. And we are moving towards more and more integration solutions that are going to deliver zero emission in operations. So partnerships with fuel cells is a no-brainer. The timing of those partnerships usually comes into commercial payback management. Partnership with current low emission engines is very practical. Partnership with all the varieties of fuels that are going to be applied to the marine industry is also practical. Or frankly, the ability to make them completely zero emission is something that we're striving and targeting here. And one of the reasons we're able to do this, if we can just go to the next slide, please, is that we are now offering full financing for these systems as well. So PowerSwap not only is coming to you as a system that can actually reduce your operating costs and reduce the capacity and performance issues associated with energy storage, but in order to make this work for clients like Maggie, we have developed the financing structures of this, because at this stage, all of our financing partners see the marine industry and the energy storage industry as something that they can get behind for the next 10, 20, 30 years, and put all the available capital in the world today into something like this. It's going to deliver emissions parity or emission zero. And that's what everybody's goal is. So thank you very much.
Awesome. Thank you so much, Brent. I'm personally super interested to learn more about the swappable battery application and who's asking for that and how it's going. I know we're seeing that innovation on other micromobility solutions a lot as well. And see, I think go zero like Maggie is already kind of becoming our slogan. Well, thank you all so much for sticking with us. We are going to close with our last speaker, David Lee from Apb Marine, who similarly to Brent kind of has a round robin of a bunch of different vessel segments that they are working on. So David Lee has spent over 20 years in the maritime engineering, production, maintenance industry. He's currently a senior account manager of new builds at Apb Marine, working on the first zero emission tug that is coming to San Diego, as well as a number of other projects. So David, over to you to close us out. Thank you so much.
Great. Thanks, Madeline. And again, thank you for allowing me to speak today. If you want to go ahead and go to the next slide, I'll just dive right into it. So everybody doesn't want to hear me talk. They want to hear what is there, what is available today. How do we get to carbon-free shipping in 2050? And I love this slide. And I guess me and Elias talk too much because we have very similar slides, but I just want to show where we're at today, where this harbor craft industry is. And I cover harbor craft for North and South America currently. It envelops both the workboat world, the ferry world, the fishing world, all those kind of combined. And you can see that today, of course, we're in the diesel, electric, methanol, LNG kind of space in most workboats. Advancing forward, battery systems are definitely coming online in a heavy ways, and definitely on the ferry side, battery is kind of a choice currently. I wish most workboat segments went from point A to point B, and you can calculate fairly easily how much power is required, but a lot of these harbor crafts, you don't know where they're going to be from one day to the next. So with that, with the technology that Elias talked to a minute ago, fuel cells is definitely the next step in that transition. And then we get into the space of where's the world going on the next fuel. At ABB, we truly feel that carbon-free hydrogen is going to be the next step in that. It could be ammonia, it could be something else, but that's where we start seeing industries kind of come to a mesh point. Only the best way to get carbon free on a large scale hydrogen, of course, is the offshore wind market that we're involved in as well, and coming to the US in a heavy way currently. So we really think this is the path to get us there, and currently where each one of those markets are. So if you go to the next slide, please. And here, all I want to do is show some examples from around the world and where each area is really trying to find their space. So first of all, a shaft generator, this again is where we combine electric power with the current engines that are out there today. This particular project is in Singapore, where we're putting electric power with an LNG engine. LNG engines are very slow to ramp up. So what we're able to do is use electric motor and some battery to get that quick ramp up time at where the LNG engines can finally catch up. And then once the LNG engines get up to speed, we're actually able to use some of that nice fuel curve points to recharge the batteries for almost free power. Then the next step is diesel electric. You see the picture here is a picture of some towboats down in South America that we have. Again, that's another application where advanced technology, electric motors, smaller engines can get us to a lot of fuel savings on these vessels. We're upwards of 30–40% fuel savings, which directly relates to the emissions. Next is diesel electric with batteries. Same thing as the one before, but in the current picture you see is wind of change. We also have the wind of hope operating in offshore wind in Europe. And they're able to utilize the battery as spending reserve. Instead of starting up all their generators, they can have the battery there and just run on the minimal number of generators at that point. The point I want to make is, again, we're trying to figure out where we're at in this space. And the only thing the top line is doing for us is making diesel engine or the LNG engine more efficient in some way. We're not getting to zero. As you see, when we transition to the area below is when we start getting into replacing all of the diesel or with alternative fuels or energy storage. So again, we get to the diesel electric with shore power. This is instead of utilizing the on vessel engines, LNG or diesel, to recharge batteries, you're able to use shore power. Next is the really exciting project that I'd love to discuss, the E-Wolf with Crowley in the Port of San Diego, 6.2 megawatt hour of battery installed on that. And it's funny, I get people kind of in the realm of how much battery that is. It's around 60 plus Teslas. And if you're like my son, who's a 7-year-old, he still doesn't quite understand how much battery that really is. And I can relate it back to his hoverboards. It's around 1,200 hoverboards that he scoots around the neighborhood in worth of battery. A great project because they can do a full day's worth of work, full shift worth of work. They come back into charge during crew change, jump back on the boat, and they're able to run back out. Next, fuel cell electric. We have several projects in this. Actually, earlier, Xiao-Li mentioned the fishing sector. It's a big kind of push in the South America region and Chile and their fishing vessels as they're looking to revitalize that segment, and hydrogen is key for them. The important thing to understand in this chart is there, again, I think Xiao-Li mentioned it as well, there's not one solution that fits for all. It is that upfront work. I think on Crowley, we had almost 2 years worth of work to figure out the right application for them and exactly how we can fit. Also meeting the goals that they had that were set by San Diego and the state of California of zero emission. And to that point, I have to say that both the ports, the state of California, other agencies are key in that project and the funding that was available to them. Otherwise, the project would not even started. And what's really, I'll leave this one last thought with everybody on the call. What's really interesting is seeing how quickly this transition is happening. So in 2011, if you look at the World Battery Forum and on their website, we had around 22 vessels in service with battery installed. 10 years later, being today, we have 333 in service and 158 planned. And what's interesting is that graph from the projected standpoint is typically flat. When you look at it the year past, that number continues to jump. So it's almost exponential in the growth on what we're seeing in the battery in the zero emission market, which is great for hovercraft. There's going to have to be some other systems come in, as others have talked about, for other applications such as fishing, offshore wind, and so forth. But it's really working in this realm to figure out which one fits the best, as we found with the Crowley project. So with that, Madeline, I'm done. So everybody else can speak, hit us up with questions and answers and so forth. Thank you.
Thank you, David. Great. Well, yeah, our last slide here is just our contact information for follow-up, which we can also send when we send the recording of the panel. But why don't we turn the slides off, and maybe just if our speakers could, our panelists could all turn your videos back on, and we have about 20 minutes here for a little bit of Q&A. So please do feel free to keep sending those in. We've got a couple. I think I'll just start with a softball, if you will, because it's kind of the billion-dollar question. So to all the panelists, sort of in your ideal world, if you were talking to President Biden tomorrow, and a lot of his maritime staff are on the call here, what would you say are the most important sort of policy or funding directives, like the policy direction that you need to scale, or like the type of funding you need to scale? What would you say in your 30 seconds in the elevator with President Biden? Elias, could we start with you?
Sure, thanks. And I apologize sincerely for my audio quality before. Hope this is better. So 30 seconds, I think that we've had a grant for this project that has been very helpful, and we've had a loan guarantee for this project that's been very helpful. In particular, the loan guarantee, I think, is interesting because it unlocks traditional financing and enables us to go forward with some innovative projects with the support of traditional commercial banks that wouldn't otherwise be possible. So I think that's a very powerful mechanism to support these large-scale infrastructure projects that are on the leading edge that traditional banks and financing might otherwise have challenges entering.
This is Graham. I 100% agree with Elias. You take a loan to a bank officer and they say, well, we've not done that before. And so, as we are trying to promote innovation, there has to be the financing in place until the banking industry starts to see these types of loans as being more vanilla. And Elias is right. Right now, they do not. So I agree with Elias 100%.
Great. David?
Yeah, my 30 seconds would be, we need the government to take the lead. We need, a lot of these hovercraft operators are traditional. They use the Southwest Airlines 737, where it's the same airline every single time. They know it. It may not be the best, but at least they have a maintenance crews plan. The government right now is not putting any of these type of systems in any of their RFPs or RFIs, or very few. And they're not proving this space to the commercial space that it is viable, that we can do it and get us to scale. So we need the government to include this in their RFPs, RFQs for vessels. Otherwise, no one's ever going to believe in it. Or it'd take a long time to believe in it, just through commercial space alone.
Great. Charlie?
My recommendation will be twofold. One is to incentivize on a route basis rather than single participant of the transition. The route base means that you have frequent demand of a specific type of zero emission vessels, and you also have fuel supplier and infrastructure providers in the same group in order to have them develop or have financial resources at the same time in order for the whole system to be built up at the same time. Another point is to not only to incentivize the zero emission technology development, but also to make current regulations on existing fossil-based fuels more stringent, make using fossil-based fuels more expensive, and that would be the other part of the game.
Thanks, Charlie. And how about you, Brent?
I'd go down a little bit of a different road. I think the role of government in this space is to define a clear playing field and set the standards that need to be achieved, and then challenge industry to do it, but present industry with a reward opportunity to achieve those goals. The subsidies don't develop industries. Subsidies create a false sense of security in developing a solution. If you look at the solar industry and how it collapsed in Europe after the tariffs were all eliminated from supporting it, and then the entire solar industry really accelerated in delivering low-cost solutions after that, largely based out of what was being manufactured in China. But that's what's driven the growth of solar EPC in the subsequent time frame. So over-subsidizing without a net gain or a strategy of how you're going to measure that doesn't support this. If we determine a carbon neutral goal or a carbon zero goal, and then challenge industry to do that and reward the people that bring those solutions to the table through lower costs or better taxes or structures like that, then I think there's less societal cost and much faster acceleration and true adoption, because the operators commercially are achieving real payback for their shareholders. And at the end of the day, that's what we're all in business to do, is deliver value to the shareholders, deliver value to society in a way that isn't become a burden on the society we're all part of as well. Sorry for the long 30 seconds.
No, and I, as moderator's prerogative, I would say I think we agree with you in that advocating for uniform standards and an end state. And I think even though there's a different interpretation of government's role in that, as David said, whether you call that grand strategy, whatever, I think uniform targets, in our opinion, that are 1.5 degrees Celsius aligned, that create market flexibility, but still are moving everyone in that same direction of the end standard for emissions. Is how I might summarize some of that. And just to elevate something Xiaoli mentioned about kind of this corridors approach, we are tracking quite closely some movement towards more of a maritime corridors framework, hopefully out of COP here in November. So keep your eyes peeled for that. There are a couple of questions in Q&A about kind of just like more of the actual engineering here. And so Jamie, there was a question from Jamie Diamond about the kind of different levels of the question, but what I want to put back to you is, I think one thing she's asking about, well, there's a new build option, right? The E-Wolf is a new tug, Sea Change is a new ferry. Are there also what's the retrofit solution? And I'm curious if you can speak a little bit about, do you have projects in your portfolios that are new builds and retrofits, or just new builds? And if you could talk a little bit about how that's going.
Do you want me to go, Madeline? I guess I will.
Yeah, sure.
So yeah, I would say both. There's a mix of it. The item that we come across most, though, or a lot of times, is somebody wants to retrofit a really old vessel that only has a 10-year usable life at the end of it, to try the technology versus going on a new side. Also, there's it's a very mixed bag on, as we've been talking about, funding on what's allowed for new build compared to what's allowed for a retrofit. So retrofits are definitely an option. Now, as we start talking about full electric compared to a traditional diesel mechanical, it's a little tricky, because you start moving center of gravities and stuff inside a vessel. And the last thing you want to do is add a system where you had to carry a bunch of water around because the vessel doesn't quite trim right. So they're all options, and I'll leave it to the rest of the team, or rest of the panelists, to give their view on it.
Just a couple of points from Switch.
Sorry about that. Got to switch the phone. Just a couple of points from Switch's perspective. I think, like Dave was saying, there's different ranges, and there's some nuance in where you retrofit. The older the asset is, there's kind of a diminishing returns on, if I'm retrofitting a 25-year-old asset that's at the end of its useful life. That's kind of might not be the best decision, and we might be better served by going to a new build. I think second point is that when we're looking at retrofit, diesel electric is one step closer to a retrofit, because it's an easier system for us to integrate fuel cells and or batteries into than geared diesel. And finally, I'd say we've looked at some retrofits through the Carl Moyer program, and there are some stipulations about previous operating life that have restricted us from doing some retrofit projects, or have kind of made it difficult to go and source some vessel and then put that into a retrofit project.
Yeah, I would say that doing a retrofit with an electric or diesel electric is actually easier than doing a retrofit with a EPA Tier 4 diesel engine, because the SCR or DPF that has to go on this Tier 4 engine burns so hot and weighs more that it makes it usually unfeasible to put on a fiberglass boat and reduces passenger capacity. Whereas you can, electric propulsion systems tend to be more modular, and so you can fit them into existing spaces easier. I'd also say they're easier to pull off a boat and put on a new boat if you needed to, because again, they're modular. But I think, as all of us are saying, retrofit, no matter what you're doing, is never as straightforward as a new boat. But I'm going to say it's easier to do an electric or electric hybrid retrofit than a diesel retrofit. But David's right. These guys know the 737 and they keep doing what they know, even if there's an easier solution. And that's why, as policymakers, it's important to get the first case examples out there so that others can operate it and see it and feel it and say, oh, this is like the 737, and feel more comfortable doing it themselves. So yes, the retrofits are possible. We have to make it easy for the first ones to do it.
I'll just chime in a small point. At the end, this is a question about Benjamins. If a retrofit demonstrates a viable payback over the life of your retrofit system, it may be the most pragmatic way to address that vessel and that operating system and the market you're operating in. When we do an analysis of a system, we currently are using about a 2 to 3 year payback metric as a go no go decision, with 7 to call it 27 years of operational performance capable in delivering cash back to the operators. And then it's a simple decision: is there enough money at the end of the life of the system to justify the investment up front? If we don't address it in that manner, then it just becomes kind of an exercise in engineering, and the engineering is viable in almost any case. It's just whether you can afford it and whether it's going to give you back the opportunity over time. So we see the retrofit market make sense about 50% of the time. If it doesn't, we just recommend their scrap and razor blades, and it's time to move to a new vessel.
Super helpful to have that sort of practical, like 50% and scrapping option. Shally, there's a question specifically, a follow up on that, of what's the relevance for vessels under 800 horsepower? I think your research specifically covers that. Is that correct?
So it covers a range of, I would categorize as relatively larger vessels in size. It ranges, it has a wide range of power. So we do, in the statistics that I just provided, there are vessels that are well under 800 horsepower. I guess that's around 500 kilowatts or something like that. So we, I think the smallest vessel that we researched in there is around 200 to 300 kilowatts. So there are vessels covered under the 800 horsepower range there. Yeah. But if the questioner is interested, I can definitely provide more specific data when the publication is ready to go out.
Madeline, if I can just add to that one real quick, what's interesting, and I'm a dumb old mechanical engineer, so getting my mind around the electrical world it wasn't easy. But what we find in smaller, and every vessel, and definitely in the 800 horsepower, there's a difference between available power, which is they need 800 power, and how much energy do they actually need. We find, we had to really truly see what kind of profile they operate this vessel. That's going to determine how much battery or how much hydrogen or any of those, how much energy do they need to have to convert into electrons. So for the propulsion motor. So the question is really, they're all there, they're available, but how do you operate that vessel that's 800 horsepower or less? We know you run the 800 horsepower from time to time, but how often? And then we can really design the system behind that. And I think Brent is probably very well adversed on that, on the how much energy, and Elias as well, the whole panel, Graham, how much energy do you need versus how much power is installed in the motors. So I'll leave that.
Thanks. That was going to be one of my questions actually for the panel, but looks like we're unfortunately almost out of time. And I think one really important question that I'd like to get out there, and then before we turn to close, is on this land side, the land side / port side infrastructure transition. So Elias, I'm curious if you could just give us a little bit behind the curtains of like, what has the process been like to negotiate the hydrogen fueling infrastructure, and how is that looking? Obviously that's going to need another master plan component to go to scale, but excited to hear how that's been working for you all for Sea Change.
Yeah.
Sorry. Yes. The best way to think about it is in a bit of a phased approach. So the first phase, while this ferry is much larger, magnitudes larger than a car, say, on a hydrogen demand side, it's still not to the scale where we're ready to, for this one ferry, build dedicated hydrogen fueling infrastructure co-located with the point of operation of the ferry. So in this first phase, what we're doing is this mobile fueling solution where we have a truck coming in. And so all that demands a source of hydrogen. Right now, we're running an informal process essentially with multiple players in the hydrogen supply realm. And then leveraging the experience that I mentioned with West Coast Clean Fuels down in LA and LNG fueling to deliver that hydrogen to the vessel. We do envision a longer term where we have a fleet of these hydrogen fueled ferries in the Bay Area, where we can then build dedicated hydrogen fueling infrastructure and have zero carbon, where you have a windmill fueling, powering an electrolyzer that then gets hydrogen created and to your ship. But that's probably one click away. Right now, we can still source green hydrogen, but it's just going to be from the existing players in the market.
Thank you. Any others want to come in on that?
Love to speak, but everybody's heard from me too much already, so I'll leave it at that. Yeah, it's not any type of energy from shore to water. It's just not an easy transition. So
Again, I think you have to apply the shore needs to the practical use of the vessel. So energy at the ports, energy at shore is almost always the last energy associated with the pipeline and grid. So it's not always available and it's not always sufficient. And the cost of infrastructure developments is extraordinary. We built the very first fully electric ship with a battery as the charger on shore, simply because it would have cost, I think it would have been nearly 25 million euros to bring enough grid down to charge the boat while it was at port. Mm-hmm. By putting a battery on the shore, we were able to extend the charging time so that the vessel didn't need to be there. The battery was present the whole trip while the vessel was gone, and we were able to charge it enough and then rapidly charge the vessel from the onshore battery to do that. And the challenge for all of us is to continue to evolve those kind of innovative ways to address the needs of the vessels and restrictions that we're all dealing. And that's one of the reasons we came up with the concept of power swap, is that we can take the batteries away, not bring the grid to the water, bring the battery to the grid. And that's just another way. And I know that if you look at the contents of this panel, there's probably 10 really, really good ideas to do something similar that are going to be implemented because they are more cost effective. And the one thing I have learned in being in this industry as long as I have is that if you're the first words out of your mouth in the morning aren't cost effective, after a few years, they soon will be.
Mm-hmm. To add to what Brent just said, and David, the description of the logistics of fuel swapping out of tanks, I can't even imagine doing what Elias has to deal with. But I think from a policy perspective, for those who are involved in policy, I hope that you're hearing that the shore charging component of electrification is not auxiliary, it's not ancillary, it's not a secondary afterthought. It is a central problem for marine vessels going electric. And in terms of policy, it's right now treated as auxiliary. It's treated as an afterthought. and it needs to be front and center as part of an integrated solution. That's cost effective, Brent. But it has to be front and center and part of what policymakers are helping people going electric hydrogen in the marine sector are doing and fully supporting, because you cannot leave that off to the side and partially support it and expect these operators to be successful implementing these projects.
Well, I have a sense that 2022 is going to be the year of port clean energy master planning for Maritime for a lot of us. I think that we're just on the cusp of getting to that. Thanks to a lot of you for bringing the first test vessels to the fore and being the pilots that get us here. So we are out of time. I'm sorry, because I think the Q&A is always the most fun part, but just want to really thank everyone on the panel for your time. Thank you to all the attendees for being here. This is obviously a critical moment here in California, where these rules are being negotiated in real time. And in the United States, in Canada, in Singapore, this is just a very fast moving sector. And so, I think the top line takeaway we hope for all of you is that the technology does exist, and now is the time to move us all in the same direction towards the transition. So with that, I'm gonna hand it over to Michelle just to close us out in our last 60 seconds. And thank you all so much from the PE side.
Great. Thank you, Madeline. You said it all really, really well. Thank you to all of the panelists. Your presentations were certainly the next best thing to being able to experience the boats firsthand. And I know I learned a lot from you about the spectrum of technology available today, including not only the vessels themselves, but also the corresponding charging and fueling infrastructure, energy storage options, and more. And really, I think that the expertise is not only on this panel here, but looking at the participant list, we've got a lot of experts in the room today. And so I hope that in the days and the weeks that follow, that folks will reach out to Pacific Environment and to Lacey, as makes sense for efforts in the Los Angeles area, to continue this conversation, as this really is the time to band together now as policymakers, investors, tech providers, fleets, Maggie, and everyone who's interested, to make sure that we are accelerating this transition to zero emissions. So thank you all for being here.